Each time you take a step, 200 muscles work in unison to lift your foot, propel it forward, and set it down. It's just one of the many thousands of tasks performed by the muscular system. This network of over 650 muscles covers the body and is the reason we can blink, smile, run, jump, and stand upright. It's even responsible for the heart's dependable thump. First, what exactly is the muscular system? It's made up of three main muscle types: skeletal muscle, which attaches via tendons to our bones; cardiac muscle, which is only found in the heart; and smooth muscle, which lines the blood vessels and certain organs like the intestine and uterus. All three types are made up of muscle cells, also known as fibers, bundled tightly together. These bundles receive signals from the nervous system that contract the fibers, which in turn generates force and motion. This produces almost all the movements we make. Some of the only parts of the body whose motions aren't governed by the muscular system are sperm cells, the hair-like cilia in our airways, and certain white blood cells. Muscle contraction can be split into three main types. The first two, shortening muscle fibers and lengthening them, generate opposing forces. So the biceps will shorten while the triceps will lengthen or relax, pulling up the arm and making it bend at the elbow. This allows us to, say, pick up a book, or if the muscle relationship is reversed, put it down. This complementary partnership exists throughout the muscular system. The third type of contraction creates a stabilizing force. In these cases, the muscle fibers don't change in length, but instead keep the muscles rigid. This allows us to grip a mug of coffee or lean against a wall. It also maintains our posture by holding us upright. Skeletal muscles form the bulk of the muscular system, make up about 30 to 40% of the body's weight, and generate most of its motion. Some muscles are familiar to us, like the pectorals and the biceps. Others may be less so, like the buccinator, a muscle that attaches your cheek to your teeth, or the body's tiniest skeletal muscle, a 1 millimeter long tissue fragment called the stapedius that's nestled deep inside the ear. Wherever they occur, skeletal muscles are connected to the somatic nervous system, which gives us almost complete control over their movements. This muscle group also contains two types of muscle fibers to refine our motions even further: slow twitch and fast twitch. Fast twitch fibers react instantly when triggered, but quickly use up their energy and tire out. Slow twitch fibers, on the other hand, are endurance cells. They react and use energy slowly so they can work for longer periods. A sprinter will accumulate more fast twitch muscles in her legs through continuous practice, enabling her to quickly, if briefly, pick up the pace. Whereas back muscles contain more slow twitch muscles to maintain your posture all day. Unlike the skeletal muscles, the body's cardiac and smooth muscles are managed by the autonomic nervous system, beyond our direct control. That makes your heart thump roughly 3 billion times over the course of your life, which supplies the body with blood and oxygen. Autonomic control also contracts and relaxes smooth muscle in a rhythmic cycle. That pumps blood through the smooth internal walls of blood vessels, enables the intestine to constrict and push food through the digestive system, and allows the uterus to contract when a person is giving birth. As muscles work, they also use energy and produce an important byproduct: heat. In fact, muscle provides about 85% of your warmth, which the heart and blood vessels then spread evenly across the body via the blood. Without that, we couldn't maintain the temperature necessary for our survival. The muscular system may be largely invisible to us, but it leaves its mark on almost everything we do, whether it's the blink of an eye or a race to the finish line.
Muscles. We have over 600 of them. They make up between 1/3 and 1/2 of our body weight. And along with connective tissue, they bind us together, hold us up, and help us move. And whether or not bodybuilding is your hobby, muscles need your constant attention, because the way you treat them on a daily basis determines whether they will wither or grow. Say you're standing in front of a door, ready to pull it open. Your brain and muscles are perfectly poised to help you achieve this goal. First, your brain sends a signal to motor neurons inside your arm. When they receive this message, they fire, causing muscles to contract and relax, which pull on the bones in your arm and generate the needed movement. The bigger the challenge becomes, the bigger the brain's signal grows, and the more motor units it rallies to help you achieve your task. But what if the door is made of solid iron? At this point, your arm muscles alone won't be able to generate enough tension to pull it open, so your brain appeals to other muscles for help. You plant your feet, tighten your belly, and tense your back, generating enough force to yank it open. Your nervous system has just leveraged the resources you already have, other muscles, to meet the demand. While all this is happening, your muscle fibers undergo another kind of cellular change. As you expose them to stress, they experience microscopic damage, which in this context is a good thing. In response, the injured cells release inflammatory molecules called cytokines that activate the immune system to repair the injury. This is when the muscle-building magic happens. The greater the damage to the muscle tissue, the more your body will need to repair itself. The resulting cycle of damage and repair eventually makes muscles bigger and stronger as they adapt to progressively greater demands. Since our bodies have already adapted to most everyday activities, those generally don't produce enough stress to stimulate new muscle growth. So to build new muscle, a process called hypertrophy, our cells need to be exposed to higher workloads than they are used to. In fact, if you don't continuously expose your muscles to some resistance, they will shrink, a process known as muscular atrophy. In contrast, exposing the muscle to a high degree of tension, especially while the muscle is lengthening, also called an eccentric contraction, generates effective conditions for new growth. However, muscles rely on more than just activity to grow. Without proper nutrition, hormones, and rest, your body would never be able to repair damaged muscle fibers. Protein in our diet preserves muscle mass by providing the building blocks for new tissue in the form of amino acids. Adequate protein intake, along with naturally occurring hormones like insulin-like growth factor and testosterone, help shift the body into a state where tissue is repaired and grown. This vital repair process mainly occurs when we're resting, especially at night while sleeping. Gender and age affect this repair mechanism, which is why young men with more testosterone have a leg up in the muscle-building game. Genetic factors also play a role in one's ability to grow muscle. Some people have more robust immune reactions to muscle damage and are better able to repair and replace damaged muscle fibers, increasing their muscle-building potential. The body responds to the demands you place on it. If you tear your muscles up, eat right, rest, and repeat, you'll create the conditions to make your muscles as big and strong as possible. It is with muscles as it is with life. Meaningful growth requires challenge and stress. Here we have an athlete preparing for a game. They've put on their gear and done their warm-up, and now it's time for one more routine: stretching. Typically, athletes stretch before physical activity to avoid injuries like muscle strains and tears. But does stretching actually prevent these issues? And if so, how long do the benefits of stretching last? To answer these questions, we need to know what's actually happening in the body when we stretch. There are two kinds of stretching our athlete might be doing: dynamic stretches, which are controlled movements that engage a range of muscles throughout the motion, and static stretches, where the stretcher holds a position to keep specific muscles at a fixed length and tension. Our athlete is currently doing a static hamstring stretch, a 30-second interval where he pulls his hamstring beyond its usual range of motion. However, while we often think of stretching a muscle like stretching a rubber band, muscles are actually comprised of various tissue types which interact to make a complex material. Rubber is elastic, meaning it resists being stretched and then returns to its original shape. But muscle is viscoelastic. This means that in addition to those elastic qualities, muscle changes under the stress of being stretched. Let's see this in action. At the large scale, this hamstring stretch is pulling on layers of protective tissue surrounding the muscle fibers, as well as the tendons that connect this muscle to nearby bones. These tissues contain elastic proteins like collagen and elastin, which allow them to slightly elongate over the duration of the stretch. At the smaller scale, these skeletal muscle fibers are comprised of millions of sarcomeres, the smallest contracting unit of muscle tissue. Sarcomeres' long, fibrous proteins can relax to elongate muscle fibers, or they can contract to shorten them, pulling on tendons and protective tissue to create the force propelling our athlete's body. And when those tissues have been stretched out, they retain their strength at longer lengths, allowing our athlete to take full advantage of his improved range of motion. Unlike a rubber band, this muscle's resistance to stretching decreases with each 30-second stretch, allowing our athlete to continually elongate his hamstring. And this improved flexibility likely decreases the chance of incurring certain muscle injuries. But due to muscles' elastic properties, this effect will be gone in just 10 minutes without further activity. The exercise from his match should elevate his muscle's temperature and continue elongating the muscle, maintaining his increased flexibility throughout the game. But once he gives his hamstrings a break, they'll retract back to their previous state. So if all this is just temporary, how can you permanently improve your flexibility? For skeletal muscles, improved flexibility comes from additional sarcomeres, which allow you to maintain strength at even greater lengths. Sarcomeres are added and subtracted to muscles depending on how frequently they're used, so improving overall flexibility requires a comprehensive stretching regimen. Plus, you need to stretch often, very often. Current research suggests at least 10 minutes a day for roughly 2 months, and since it's unsafe to hold any stretch for too long, it's recommended that you break up your stretching within any given session. Frequent stretching also makes lasting changes to your brain. The more you stretch a muscle, the higher your pain threshold becomes, allowing you to stretch further and further. Long-term improvements to your flexibility can provide a better range of motion for your joints, potentially reducing your risk of muscle injury in the short and long term. But it's also possible to stretch too much, as flexible people can move their joints in potentially dangerous ways. Stretching also isn't helpful for every kind of movement, especially those where muscle injuries aren't very common. For example, long-distance running only involves a small range of motion for the joints involved, so stretching is unlikely to prevent that sport's most common injuries. When it comes down to it, different lifestyles require different kinds of mobility, and no single stretching regimen is flexible enough to fit every situation. Now you know how to keep your muscles pliant. Next, learn how to make your muscles stronger.
The victory of the underdog over the favored team, the last-minute penalty shot that wins the tournament, the high-energy training montages. Many people love to glorify victory on the playing field, cheer for favorite teams, and play sports. But here's a question. Should we be so obsessed with sports? Is playing sports actually as good for us as we make it out to be, or just a fun and entertaining pastime? What does science have to say? First of all, it's well accepted that exercise is good for our bodies and minds, and that's definitely true. Exercising, especially when we're young, has all sorts of health benefits, like strengthening our bones, clearing out bad cholesterol from our arteries, and decreasing the risk of stroke, high blood pressure, and diabetes. Our brains also release a number of chemicals when we work out, including endorphins. These natural hormones, which control pain and pleasure responses in the central nervous system, can lead to feelings of euphoria, or what's often called a runner's high. Increased endorphins and consistent physical activity in general can sharpen your focus and improve your mood and memory. So does that mean we'd get just as much benefit going to the gym 5 days a week as we would joining a team and competing? Well, here's where it gets interesting. Because it turns out that if you can find a sport and a team you like, studies show that there are all sorts of benefits that go beyond the physical and mental benefits of exercise alone. Some of the most significant are psychological benefits, both in the short and long term. Some of those come from the communal experience of being on a team. For instance, learning to trust and depend on others, to accept help, to give help, and to work together towards a common goal. In addition, Commitment to a team and doing something fun can also make it easier to establish a regular habit of exercise. School sport participation has also been shown to reduce the risk of suffering from depression for up to 4 years. Meanwhile, your self-esteem and confidence can get a big boost. There are a few reasons for that. One is found in training. Just by working and working at skills, especially with a good coach, you reinforce a growth mindset within yourself. That's when you say, even if I can't do something today, I can improve myself through practice and achieve it eventually. That mindset is useful in all walks of life. And then there's learning through failure, one of the most transformative long-term benefits of playing sports. The experience of coming to terms with defeat can build the resilience and self-awareness necessary to manage academic, social, and physical hurdles. So even if your team isn't winning all the time, or at all, there is a real benefit to your experience. Now, not everyone will enjoy every sport. Perhaps one team is too competitive or not competitive enough. It can also take time to find the sport that plays to your strengths. That's completely okay. But if you spend some time looking, you'll be able to find a sport that fits your individual needs. And if you do, there are so many benefits. You'll be a part of a supportive community. You'll be building your confidence. You'll be exercising your body, and you'll be nurturing your mind. Not to mention having